Bismillahirrahmanirrahim. Today we are explaining the concept of hyperconjugation in organic chemistry. Our hyperconjugation is also called no bond resonance. Here a sigma bond of CH, this is the sigma bond, which is conjugated with a pi bond or with positive carbon, participate in resonance. Hyperconjugative resonance can explain the electron donating effects of an alkyl group. The groups like having 3 hydrogens, where CH sigma bond is in conjugation with the pi bond. Similarly, carbon having 2 hydrogen and carbon having 1 hydrogen, they can participate in the hyperconjugation. Here we can see the example of toluene in case of figure number 1. The CH sigma bond is in conjugation with pi bond in the ring. So CH bond, single bond, double bond. So this sigma bond is in conjugation, so the hyperconjugation can occur. So you will get this resonating structure, and then correspondingly this come here and this come here to give this, and similarly this would be the result by shifting the electrons from here and then from here. So you can see here between this carbon and hydrogen there is no bond. That is why we also called it as no bond resonance. Similarly, from this oxygen, the same can occur. This bond, sigma bond, can transfer here. This pi bond can transfer here. You will get the same resonating structure as here, and the same, this same as here, same as here. Similarly, by taking the third hydrogen in toluene, this sigma bond can transfer here and this pi bond at the corner. So you are again getting the resonating structure like 2 and 3 and 4. Here in example number 2, you can see at carbon 1, we have 3 hydrogens, and all these 3 hydrogen, they are in conjugation with the pi bond, which is at carbon number 2. So this hydrogen can take part in hyperconjugation. The sigma bond between C and H can shift here, and correspondingly this pi bond would shift at this carbon, and in this way we get this resonating structure. And here you can see there is no bond between carbon and hydrogen, so no bond resonance. Similarly, and this hydrogen will take part in the hyperconjugative resonance to give the same resonating structure, and similarly the third hydrogen will take part to give the similar structure. All three hydrogens at carbon number 1, this is carbon number 1, are alternate to pi bond. This is the pi bond at carbon number 2. So all are hyperconjugative hydrogens. And this is another example where we are showing the hyperconjugation. This CH bond is at conjugation with this carbon, which is electron deficient or positively charged. So the hyperconjugation can occur here also. And any type of the example where this situation would be seen, you can do the hyperconjugation. So this CH bond, sigma bond come here to give the pi bond. And between hydrogen and carbon, there is no bond. Similarly, the other hydrogen can participate in the hyperconjugation to give this structure, and the third hydrogen can participate in the hyperconjugation to give this resonating structure. So it depends upon the number of the hydrogens which are at alternate position to C plus or which are conjugated to C plus. So we can decide how many resonating structure would be formed.